Hello everyone. Today I learned about the R programming in and that it can be used in remote sensing as well as the raster data. So I am going to use the raster data and show it in a map. So I have downloaded TIFF image from one of the website in this website, and I have used all the codes and that used in this exercise are from this website data carpentry. So I am going to start my lesson. So these are the codes I have used in Jupyter. So I have managed to write these things from data carpentry, and I will just upload it in my github site. So for this, I will first install the packages required for it. So I will install these packages by using install.packages, and this is a um, our style of installing the packages: dplayer, ggplot2, raster, raster rgdal, rasterviz, visualization, and sf. And then after installing these packages, I will import these packages like raster, rgdl, ggplot2, and dplayer. So I will just hit shift and enter, and these are already installed, and it will be some of these are will not be installed again. So just skip these things, and I will install the data using this link. Yeah, when I go to this link, I can found this will be downloaded directly. So I will just cancel this because I have already downloaded it, and I have put the download folder in here, downloads, in my download folder. So we can see here, like if you go to my download, so this is the local drive. So I have the file mm, in neon, and then harv dsm, okay, and then harv dsm crop. So I will use this file location here, harv dsm crop .tiff. So we, while copying this, we should use two slashes here, and I will also play this, run these things, and it is calling the digital information. So the information will be shown like this, like the information of this TIFF image, like there will be rows, columns, band 1, so all the things, projection units, and all the summaries will be shown here. So if we wish to store this information in R, we can do the following things, like we can call capture.output. So when we call this, we can add these things to the harv dsm crop info. So when I again run this, this is wrong, this has already been run, and I will first will load our raster file into R and view the data structure. So for this, I will load again the raster file, and I had used this for the GDAL info, so only the information were shown. Now I will use the raster and the same file location and save it in dsm-hrv. So when the dsm-hrv is called, we'll see some output, like it will show the class, dimensions, resolution, extent, CRS projection, and sources, name, values, and so on. So maximum and minimum values are shown. So you can read all the values using R. Then after that, we would summarize all the things uh, of this variable, which we have included raster information of this harv dsm crop. So then just hit enter, we can see warning message in that local. So this same warning message is saying summary is an estimate based on a sample of 4.1331 percentage of all cells. So only some of the percentage are shown. It's just a warning message. So the mean first quartile, median third quartile max are shown, but then we will calculate the statistics using every cell in the raster. It will take the random sample of 100,000 cells and calculate from that instead. So let's see what will it give. So these are almost the same, like only the values after this are just shown are different here. So this is maximum amp. I think they will just use like decimal changes there. Now you may not see major differences in the summary as in so there is no major differences here. So now to visualize its data in R using ggplot2, we have to first convert it to the data frame. So without converting it to the data frame, we cannot visualize that in ggplot2. So for converting it to data frame, we would convert the same data into the data frame and will assign it to this variable. So this has been assigned. Now we view the structure of our data. So this data frame, the file we had just created, we will see the structure of these files. So data structure will be like this. So now we can visualize this data in the ggplot by writing this code. So the code is like ggplot plus raster. So the data will be this latest data frame data, and AES will be x equals to x, y equals to y, fill equals to, the fill will be HARB underscore DSM crop. Now and then I don't know about these things, like we can see here, we will set the color scale to scale fill Firidis C, which is a color blindness friendly. So this is just a color which we will see in the output. So code underscore quick map, we will also use the code underscore quick map function to use an approximate Mercator projection. So this will use the Mercator projection here. This approximation is suitable for small areas that are not too close to the poles. Other coordinate systems are available in ggplot2 if needed. You can learn more about okay, we will also do that things in the next chapter. So just run this code. We can see the output as image file, and that image file could be saved as a PNG or JPG file. So we have to wait for some time. So we can see the map, output map here. Okay, now I will save this image as a PNG file, and I can view this image. I can download and view this image. So this is the output map. We can just see the things here, like this will be x coordinate, this will be y coordinate, and DSM crop, this will be the legend. Okay, thank you so much for watching.